Okay, in this video we're going to learn how to integrate functions involving both e as well as the natural logarithm ln. So there are two rules in this video that we're going to go over. The first is how to integrate any function, where it's e to the power of a function, so e to the power of f of x, and how to integrate any function where it's f dash x, the derivative of a function, divided by its original function. So to integrate the first function, the first thing we need is the derivative of the power next to it. So we need the derivative of f of x to be lying already there, or we can introduce it if it's a constant. But so long as we have the derivative of the power next to it, the derivative of this simply becomes e to the power of f of x plus c. And if we have a fraction where the derivative of the denominator is on the numerator of the fraction, well, this simply just becomes the natural logarithm of the absolute value of f of x plus c. And let's go through a few problems in this video today. We'll start with e and then work our way to ln. The first problem we're going to be doing today is what is the integral of e to the power of 6x dx? Well, we need the derivative of the power to be right next to it, which is, in this case, the derivative of 6x is simply just 6. So we need there to be a 6 next to our integral. However, are we simply allowed to just multiply our entire thing by 6 just because we felt like it? Absolutely not. So to counter our addition of the 6 being added into here, we also need to times it by 1 on 6 on the outside. So now that we have this integral here, we know the integral of 6e to the power of 6x is simply just e to the power of 6x. But we also have to times it by the 1 over 6. So it's equal to divide by 6. And then we can do plus c. And that is how you integrate the first integral. The next integral we're going to do is what is the integral of e to the power of 2x minus 3x dx. We're going to take this slowly. We're going to integrate this function first, then we're going to integrate this function. So the way I'm going to do that is, firstly, I'm going to just separate the integrals. This is the same as the integral of e to the power of 2x dx minus the integral of 3x dx. To integrate e to the power of 2x, all we simply have to do is make sure there is a 2 next to our function. However, we're not allowed to just randomly add the 2 just because we felt like it. So again, we have to times it by a half. So now what we can say this integral equals to, we can say this integral is simply e to the power of 2x, but we also have to times it by the half, or divide by 2. And then the derivative of the integral of 3x is simply add 1 to the power, so 1 plus 1, and divide it by the new power. So it becomes plus 3x squared divided by 2 plus c, and you can also just simplify this as e to the power of 2x plus 3x squared divided by 2 plus c. Let's keep going. The next question that we're going to be doing is the integral of e to the power of 2x minus e to the power of x on 2. Again, just for simplicity's sake, I'm just going to separate this integral. I'm going to separate it as the integral of e to the power of 2x dx minus the integral of e to the power of x over 2 dx. The integral of this first integral can be worked out, the integral of this first function can be worked out by simply having the derivative of the power next to it. And the derivative of 2x is simply 2. Now again, we need to times by a half to cancel out the effect of the 2. And we can also do the same for this function here. The derivative of x divided by 2, or in other words, a half x, the derivative of this is simply a half. And if we want to cancel out the effect of timesing by half, we have to times it by 2 on the outside. So this first integral over here will simply become e to the power of 2x divided by 2 minus e to the power of x over 2, but then we have to times this by 2 plus c. And that is how you work out the integral of this function here. The next function we're going to be doing is the integral of 3 minus e to the power of 2x divided by e to the power of x dx. And again, I'm going to separate this as two separate integrals. I'm going to separate it as the integral of 3 over e to the power of x minus the integral of e to the power of 2x divided by e to the power of x. Now this first integral, it would be in our best interest to make it such that all we do is have the e to the power of x on the numerator. So I can, instead of writing 3 over e to the power of x, I'm going to rewrite it as 3e to the power of negative x dx using our index rules. Then for the next question, next integral, I'm also going to do the same thing. The integral of e to the power of 2x divided by e to the power of x is simply the same as the integral of e to the power of 2x take x. And 2x take x is simply just x. So it becomes the integral of e to the power of x dx, and this is very easy to integrate. For the first integral, this integral here, we need to have the derivative of the power next to it, and the derivative of minus x is simply negative 1. So we need a negative here on the inside as well as on the outside. So this integral becomes 3e to the power of 3e to the power of negative x, and then you can just have a negative at the front, so negative 3e to the power of x. And then what we can do is integral of e to the power of x. Well, that's very special. The integral of e to the power of x is e to the power of x, and then we can just do plus c. Let's keep it going. We can also do now the integral of e to the power of negative x plus 1 dx. In this case, I'll make it minus 4x. Okay, so to integrate this, I'll do this one separately. So I'll separate these integrals as e to the power of negative 4x dx plus the integral of 1 dx. To integrate this first integral, we need to have the derivative of the power next to the function. So we need to have a negative 4 where we currently have our thingies. So negative 4 here, but we can't just have a negative 4 just because we felt like it, so negative a quarter on the outside as well. So now the integral of this simply becomes e to the minus 4x divided by minus 4, and I don't really like having negatives on the fraction itself, so I like just doing the whole fraction as negative, plus the integral of 1 is simply just x plus c. That is how you integrate e to the power of x and its functions. Now let's have a look at using some ln of x functions. So how would we integrate functions that look like this? How would we integrate something like 4 divided by x? Well, I recognize I have a fraction, and if I look at the denominator, I can see that the derivative of the denominator is almost on the top. The derivative of x is just 1. And what I'm able to do here is I'm able to rewrite this integral as the integral of 4 times 1 over x. And you can see that now I do have the derivative of the denominator on the top. But this 4 is still also inside the way. It's in the way of the actual integral itself. So what you're allowed to do is you're allowed to use the rule that says that the integral of any function k f of x, that is just the same thing as k times the integral of f of x, because it's just a constant. So let's use this rule and just move the 4 out to the very front. So this is the same thing as 4 times the integral of 1 over x. And now we have our ln rule. The derivative of the denominator is simply on the top. So we can just say this is the same thing as the ln absolute value of x plus c. But we also have to remember that there is a 4, so we can keep the 4 right there. Let's keep going. The next question we're going to be doing is what is the integral of x squared divided by x cubed plus 3? Well, let's check what the derivative of the denominator is. The derivative of x cubed plus 3, that's simply equal to 3x squared. And I kind of have x squared, 3x squared on the numerator, except I'm missing the 3. So all I'm going to do is I'm just going to have the 3 right here. Again, you're not allowed to just introduce variables just because you feel like it. So I'm also going to do a third on the outside. So now that I have this integral here, I can integrate very nicely. This just becomes ln absolute value of x cubed plus 3 plus c. But then you also have to times by 1 over 3. And that is how you integrate that function. Next function, what is the integral of x plus 2 divided by x squared plus 4x? Pause the video and have a go yourself. Well, what is the derivative of the denominator? Well, the derivative of the denominator, x squared plus 4x, that's simply equal to 2x plus 4. And do we have 2x plus 4 on the numerator? Not really, but if I times my entire numerator by 2, I will. Right? So I can literally just times everything by 2 and everything is all very nice for me. But am I just allowed to times everything by 2 just because I felt like it? Once again, no, you are not allowed to. So what I'm also going to do in this case is I'm just going to times by half on the outside. So now this integral can simplify down to ln absolute value of x squared plus 4x plus c, and then remembering to have the half. Alright, our next integral is the integral of tan x dx. Hold on a minute. How are we supposed to use our ln rules to work this out? This isn't even a fraction. Well, what we can recognize is this is the same thing as the integral of sine x over cos x. Okay, so we can use this feature to now introduce in ln's. What is the derivative of cosine x? The derivative of cosine x is simply minus the sine of x. So if we have minus the sine of x and we have a sine x on the top, all we can do is introduce our negatives. You can introduce a negative inside here, but you can't just do that just because. So you have to have a negative on the outside as well. So the final integral of this simply becomes the ln of absolute value of cosine x plus c, but you also have to remember to bring back the negative that's outside the integral. And that is how you integrate tan of x. Let's keep going. How do you integrate this function here? Well, to integrate this, we need to recognize that the derivative of the denominator is almost on the top. The derivative of the denominator, in this case sine 2x, well, that's simply the same as cos 2x, but then you also have to times by the derivative of the inside angle, which is just 2. So that's almost on the top, that's almost on the numerator, but we just have to introduce a 2 inside and a half on the outside. So our new integral becomes ln absolute value of sine 2x plus c. And in this case, you just need to bring back the half. Now this next question is going to be a trick question. I would like you to work out what is the integral of 3x take 2, just 3x divided by x squared plus 3. Work out the integral of this here. Okay, so let's go through it. To integrate this, we need to recognize what is the derivative of the denominator. The derivative of the denominator in this case is simply just 2x. And we almost have that on the top. We almost have a 2x on the top. So all I have to do is make the 3 turn into a 2. And I can't just do that just because. So all I'm going to first do is bring out the 3 to the outside, because it's a scalar multiple. So you have x divided by x squared plus 3 dx. And now I'm just going to introduce a 2 here. So I can make it 2x, but I obviously just can't do that out of my free will. So I have to also do divided by 2 on the outside. So it becomes 3 over 2. So that means the integral of this entire function simply becomes the ln of absolute value x squared plus 3 plus c. But then I also have to do 3 over 2. Is that really my integral? No, it is not my integral. We need to recognize, what does the graph of x squared look like? X squared plus 3 more specifically. Well, we know that x squared, if we were to draw out the graph of x squared, is simply just a quadratic. And it's a quadratic which has its x-intercept, which has its intercept at the x-axis at 0, 0. But now if we do x squared plus 3, okay, if we do plus 3 to our entire graph, what we need to recognize is our entire function gets shifted upwards. It gets shifted in the y-axis by 3 units. So that means our vertex, our turning point, will now be at 0, 3 instead. But is there really a need for an absolute value then? Why would we need an absolute value if every single value on our quadratic is a positive number? There are no negative numbers in order to take the absolute value of. So for this question here, the correct answer would actually be without the absolute value. It would be without the absolute value, and it would just be this. So be very careful for questions like this. You need to check whether or not the absolute value for ln integrals actually apply. So in this case, it does not apply.